You come from a non-traditional background. How did you get into software engineering and computer science?
When I joined the team, I would say I knew how to program, but I had never thought of software engineering. I had never taken a course. In the first year working with that team, I had very critical code reviewers who really beat best practice into me. My first change had like 50 comments. It was basically me adding some CSS to a web app. The problem with this like query decomposition is that the model doesn't always work the way you'd want it to work, especially because a lot of the models that are trained on public datasets do not understand internal company semantics. I think as agentic things increase in reliability, this will become even more awesome.
You've been at Google for 10 years, so like how did Google evolve? This is probably the most complete LLM course I've seen so far, from beginner to advanced developer by Towards AI. It's basically a one-stop conversion for anyone who wants to become an LLM developer, and the course has over 90 lessons to go from beginner to advanced in the field. It's both very practical and industry focused, but also quite technical, and you will cover a lot of technical topics like RAG, fine-tuning, agents, audio, and caching. So if you're interested, check out the link in the description, and don't forget to use the code AIStories10 to get a 10% discount. All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact, and I will be your host. So today, our guest is Max Buckley. Max is a senior software engineer at Google with over 11 years, even more of experience at Google. He's specializing in machine learning, in applied statistics, and in operation research. He joined Google in 2013 as a business associate intern. So yeah, climbed the ladder, did various positions, and we're going to talk about all of this in this episode. Regarding studies, Max got a Master of Software Engineering from Oxford and a Bachelor of Business from Munster Technological University, and got other degrees as well, did quite a lot of studies. So in this conversation, we'll talk about various parts of the field. We'll start from Max's business career, talk about computer and software engineering, talk about data engineering, and finally talk about AI, machine learning, and LLMs. So if you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, so let's start now. Hi, Max. Super excited to have you on the show. First thing I wanted to ask is, well, you come from a non-traditional background. How did you get into software engineering and computer science? How did you get into that?
Yeah, so it's a kind of interesting story. My father worked in IT my whole life, so growing up I always had computers, which is obviously normal now, but in the early 90s it wasn't so normal to have a computer in your house. So I had like my first computer in my bedroom about 1995, or like not so much programming then, but hacking away in Windows 95. And I was always a big PC gamer and hobbyist, I suppose. And I always planned to study computer science, but when I was about 16 and having a conversation with my dad about career options, he was advising me to not study computer science and to do something else, and that I could move into computing anyway. I took his advice. I ended up doing business studies because it was broad and non-specific, non-committal, I suppose. And that went well, but I felt it was a bit fluffy. Like I remember in sort of second to third year thinking like a lot of the subjects I preferred were the more quantitative, more tangible subjects, and a lot of them, ones that were more sort of qualitative, felt a bit more subjective, and I wasn't as enthusiastic. So in parallel, I started programming again, and I had programmed when I was a kid because, as I say, at some point we had various computers in the house, and I learned to program in Visual Basic. So when I was kind of 20 or so, I started programming Java, and very quickly moved into sort of web development, and then R, the statistical programming language. So I started using that. And this was exactly the same time that Coursera appeared. So like by coincidence, MOOCs became a thing. And initially I started looking into MOOCs that were related to what I was studying in college, so sort of business. And then from there, I was more interested in the finance ones. And from there, I was more interested in the statistics part of finance. And from there, I ended up at sort of data science, computer science. So kind of found myself drifting in this sort of direction. And then very kind of fortuitously, I applied for an internship in Google for the sort of summer of 2013, back in 2012. And Google reached out to me. They had a business associate intern role, and they were looking for someone with kind of some sort of quantitative and programming skills, but also kind of business background. So I fit the bill and got that internship. And the rest is history, which we'll go through, I suppose.
So can you talk a bit about this first job at Google, and how did you move from this first job as an intern to being a senior software engineer working with AI, with LLMs? Like, how did your career evolve? And also, how different was Google in 2013 compared to today?
I'll take the first part first. So my career at Google, I would say, is quite unorthodox in the sense that I've moved team more than anyone I've ever met in the company. I don't know. I'm naturally very kind of curious and always sort of hungry to work on new things, new problems, learn more. And so as such, I've moved like probably 10 different teams. And for some of these teams, it's also not just like moving to work on like a sister team, but rather hopping across the company, hopping to a very different area or function. And this is, intentional. I mean, in the early days, especially like when I joined as an intern, at that point, I kind of decided data scientist was my target job, what I wanted to do in the future. And I started looking at all these data scientist job listings and looking at what skills were needed and trying to build those skills to kind of get myself there. And I would use that when I would decide what role to change to next. I would say, like, what will this next role add to my portfolio of skills? Like, what will this develop? And if it moved me in like roughly the right direction, I would take it. Like it doesn't have to be perfectly aligned, but even sort of.
But your end goal was always to be a data scientist. Like that was your kind of dream job.
I mean, at the time, data scientists hadn't yet kind of split into the kind of like different roles that we see today. It was like back in 2013, data scientist was the unicorn who would do everything sort of machine learning and machine learning adjacent. They would be like a statistician, software engineer, data analyst. Nowadays, there's more clear sort of delineation. And I think even then, if you had told me about this like split, I would have said machine learning engineer was what I thought was more interesting. But yeah, data scientist at the time was kind of what I was viewing as the target. So every move I made or every kind of decision of like what to study or what to work on as side projects was often informed by that.
How did you decide that then? Because, okay, you see data scientist as your dream job. So you see that as like a range of skills or technology that you need to learn in order to become a data scientist. Like, what did you learn and how did you do to get there?
I don't know where exactly it started. Like, I couldn't say, I mean, obviously data scientist was not a term that I was familiar with when I was younger. But at a certain point, I started hearing about this job, this data scientist job, and it sounded like this interesting kind of combination of skills, right? You had to kind of analyze data and have insights and build these models that could predict. It just seemed to me like an intrinsic set of interesting things. And I mean, also, the media at that point was very much pushing data scientists. Hal Varian, the chief economist at Google, called it like the sexiest job of the decade or something like that. And there were all these like articles being written about how cool data science was. And then personally, when I started doing Coursera and I started doing data science Coursera's, I found them the most interesting. Like I found it super interesting, okay. The fact that we could predict, people's gait using random forests from sensor data on like smartphones. I was like, wow, this is amazing. Or seeing what was going on in different machine learning research, that was really sort of exciting to me. And I kind of wanted to be working on that or doing that kind of work.
Okay, makes sense. And so yeah, let you continue on your path at Google then. This is how basically you decided to change team based on new skills that you would acquire. So on what team did you work on? What did you do?
Yeah, so I'd say when I first joined, I was a business associate intern that was working on what's called marketing finance in the London office. And And that was a 3-month internship. And the plan was that I was going to do a master's in financial economics in September. But while I was there, managers contacted me internally and suggested that I didn't have to do that master's, that I could just join as a full-timer straight away. So while I was an intern, I interviewed for a full-time role and got offered a full-time role in Dublin office to be a business analyst. So I got that role and I finished my internship at the end of August and started as a full-time employee 2 weeks later, or 2.5 weeks later. So there was a quick turnaround. The first role as a business analyst, it was a analyst type role. I mean, it probably wasn't like, it wasn't like my dream role. It was like doing analysis and reporting for sort of support teams under the kind of business org. But again, it was a good opportunity to get into the company and to, develop my SQL skills, my programming skills, Python, Google Apps Script, which is like JavaScript running on the cloud. So I kind of took the opportunity to kind of like challenge myself and grow my skill set, even when I'm not in a role that I'm super enthused about, I still, if I'm ever asked to solve the same problem twice, I'll solve it a different way every time, which is super inefficient, but super good for learning.
So can you go into that? Like, that's interesting. How would you do? You would like use different technologies, for example, and learn something new?
Yeah. So, I mean, the way Google is sort of structured is like a huge like global company, right? So there's like lots of different departments and they're sort of somewhat segregated. Like the business part of it, you'll be working with the people in the business side, you'll work with salespeople, support people. You're not necessarily working with engineers. But of course, you still have access to all the internal documentation and a lot of the internal systems are there and you can use them, you can poke them. So, I was always like reading these documentation and like implementing things and doing things because I could, just like out of curiosity. So, if someone was like, hey, can we identify which customers are going to churn? And they just wanted me to like give them a list of customers. I'm like, hey, can we like build a random forest regression model and set it up to run regularly automatically? And the answer was yes. And I was like, that's much more interesting and educational for me. Also, it looks cool on your CV, which I guess is like a theme in my life that I think about, like what shows the skills that I want to show for like future opportunities. Like what's a good CV win? Because some projects are kind of things that like you put a lot of time in, but they don't help you sell yourself. And other ones are like, wow, that sounds really cool and like what we want in our future team or company.
So the stakeholders ask you to get this list of customers. You could just look it up and give it to them by, I don't know, writing a query, but you decide to do things more complex to learn stuff, learn how to build an algorithm, learn how to predict churn, things like that. That's super cool.
Exactly.
And do the stakeholders, I mean, they're quite nice because you would take much more time, right, to build this algorithm and everything. So is it frequent to do that? How did you find the time to build those things on the side in some sense?
I mean, I guess it's like iterative, right? Like, I mean, I don't mean to say that I spend like months doing it, but like to kind of build a prototype or like proof of concept and come back to them like a week later and be like, here, I've got this predictive model and predicted, and we've done some back tests and we say, hey, it's this good. And then, they're very excited about it when you pitch it to them. I mean, some of them maybe understand, other ones are maybe not so like technically adept. But yeah, I mean, as I say, it's inefficient in the sense that you're not necessarily delivering as many things as you could if you challenge yourself to deliver them in a more interesting way.
It can become efficient if those stakeholders ask you this, 10 times or 20 times, then you might just as well automate the process.
I think I have a very low tolerance for like rework though, like much lower than other people. Like one constant in my life is every time I join a new team, something breaks after a week and I have to fix it. And I ask the, other people on the team, how often does this happen? And they're like, oh, it happens every week, but it's fine because it only takes like a half an hour. And I'm like, can we like fix it permanently or automate the fix? And they're like, no, it's not worth it. It only takes half an hour. And I'm just like, I'm much happier to spend like several days fixing it forever and never think about it. But that's very much my own weird.
Yeah, I think it's a good point. I mean, if it happens frequently, it's the short term versus long term thinking. Like in the short term, obviously it's quicker to just fix the bug manually, but in the long term, if you manage to automate this process, it will be much better. So just need
I
to.
also think that there's a kind of a difference, or like I have a problem with some people's calculus, like where they think it only takes 30 minutes, and what they mean is it only takes 30 minutes for them now in their experienced state, right? Whereas for every new person, it takes like half a day or whatever the first time, and maybe it gets faster. So it's, if you can fully remove the problem, then its value is not just like half an hour per week. It's half an hour per week, plus you've like removed some piece of cognitive load. You've probably also like removed some risk, because oftentimes for these things, there's like some weird backfill job you have to run, or you have to have like edit access on the database to like edit something. And it's like, why are we giving everyone in the team edit access on the database? Oh, because we don't want to automate the process. Okay.
And so going back to your career, so you start as an intern, you have this business analyst job that's not your dream job, but you manage to learn things on the side to go towards this data science dream job that you want to have. How do you evolve then within Google, and how do you move on?
So Google has this like rule that you're supposed to spend at least a year in a team. It's like a guideline. It's not like 100% strict, like they do occasionally flex it. So I was pretty sure early on that this wasn't the role for me, or not that there is a role that I'd stay in forever, but like I was pretty sure that I was like moving on when that timer ticked out. And so I early on started like reaching out to lots of different hiring managers for different teams in Dublin to learn more about what opportunities were there, seeing which ones align with my skills. And there was one particular manager who I really value, like my relationship with him. He basically, had this role in his team, and I spoke with him, and then I spoke to several people on his team, and I went back to meet with him to tell him I wasn't interested, that I wasn't going to join his team. And then he actually pitched to me like the most sort of interesting kind of pitch I've ever had in my career, I suppose, where he sort of suggested that in his team there was a growth path. He sort of suggested a kind of 3 to 5 year plan that would take me from joining his team to becoming a software engineer. And he suggested that if I had gone back to finance to work on like automation and tooling for them, that it wasn't clear where I would go from there. Whereas his team worked closely with an engineering team, and they had a structured program to do like a rotation with those engineering team and potentially transfer there. And so when he told me this plan, when I saw his like vision, I was really like on board. I was like, sounds good. He was like, you do the core job and ramp up for 6 months, and then you can do automation for the next 6 months to 12 months. And then you can do this rotation with the eng team, potentially transfer there. And I was like, amazing. And things went even better than that. So from the moment I joined his team, I started doing automation from day one. I never really fully got ramped up on the core job, never got fully trusted on the core workflows, just developed the tooling.
Great. What kind of automation was that?
So that was in what is now called trust and safety. So it's basically the part that prevents fraud and abuse of Google products. So it's about like making sure that malicious people don't, abuse Google policy to make money, or make money through violating policy. So I was working a lot on AdMob, which is in-app advertising. So, you didn't want people to be able to monetize Google ads alongside illegal file sharing or adult content or violence or these kind of things. So it's about like identifying people who are violating policy and suspending sort of ad serving, or even removing them from Google Play Store. And kind of ideally doing this at scale, right? So not just you personally like reviewing an app and going, this looks bad, but ideally you can automatically identify thousands or tens of thousands of apps and remove them en masse.
And is this not an AI problem then? Because I see the software part, you can have a rule-based thing, but you could also build an AI algorithm, right, for that?
So yes, and I mean, I don't know where they're at today, but I imagine it's even more yes now than it was then. But even then, I mean, there were large parts of it that were automated, right? Or like that there were different machine learning algorithms in different parts doing flagging, prioritization, identifying, classifying different parts is problematic. So there was a lot of different signals being integrated in different places. But there was still a kind of, and there still are like human teams that are involved in some level of operations, quality assurance, whatever else.
Okay, makes sense. And so this is where you kind of learn more about software engineering and become a software engineer.
Well, yes. Yeah, so there was one guy I worked with who I'm really grateful for as well, who, when I joined that team, I would say I knew how to program, but I had never thought of software engineering. I had never taken a course in algorithms or testing or any of these things. Like, I could program. If you gave me a problem, I could give you a solution, but it wouldn't scale. There'd be like terrible or no commenting, or there'd be commented out blocks of code. I would never even think about like how it looks. I would never think about how to test it or extend it later until I want to extend it. So in the first year working with that team and working with their eng team, I learned like a tremendous amount because I had these very critical code reviewers who really beat best practice into me. My first change had like 50 comments. And it was basically like it was basically me adding some CSS to a web app.
I mean, that's how you learn, right? You make 50 mistakes and then
absolutely,
and then 40 and then 30.
Absolutely.
And so you learn about software engineering in this trust and safety team. How do you move to AI then? How did you get into the AI field?
Yes, so I'll say my North Star was data science at this time, right? So as I saw it, programming was one of the two things I had to get. And the other thing I needed to get was this like strong quantitative background. Mm-hmm. So while I was in this team, in parallel, I was also doing a postgraduate certificate in statistics in Trinity College Dublin. So I was working on my quant skills in sort of parallel to this junior engineering type work. So I was also getting to implement some of my statistical learnings in work, which was pretty cool. So I was like, some of the things I was learning in statistics, I was able to go into work and implement. So that was one of the things that was nice about the analyst team. We had this kind of broad scope. But when I finished that particular postgraduate certificate, that was a year, I immediately started a master's in business analytics. That being a kind of something at the intersection of business and computer science. And again, that was even further sort of towards that kind of data science direction. But I was still in work then. I had joined the engineering team full time, and I was doing all sorts of infrastructure work, both more back end than front end, but also some kind of front end. So I guess what people would call like full stack engineering. So at this point, there was still this like split where, my personal life or my interest was very much in this sort of machine learning data science space, and my part-time study was aligned with that, but my like full-time job was, full stack development with no real data science component to it. Mm-hmm. And that was the case until 22, but in 2019, I finished, or end of 2018, I finished the master's in business analytics. And I also applied for a job in Google Zurich. So I wanted to transfer to Zurich office. And I was just like looking for a team here here where I am now in Zurich, a team in Zurich that was interested in my profile. And so I found this particular role in a team called Shopping Eng Prod. And on paper, I wasn't that excited about the role. Like, I thought I would just spend 12 months there, like I tend to do. But actually, when I got there, everything was amazing. Like, the management was amazing. The colleagues were great. The projects were super interesting. And again, I found myself in a lucky position where I had a lot of flexibility and some great mentors. So I ended up spending like 4.5 years there.
Okay.
But that work was very much what I would call data engineering, or rather like the infrastructure for data engineering. It was like we weren't like writing a data processing pipeline, but we were writing the infrastructure to run tens of thousands of data processing pipelines across the company.
Cool. How do you do that? Like, which tools do you use? What are the challenges?
Well, so I mean, in Google, most things are like internal Google infrastructure, mm-hmm. So it doesn't really use like external visible tools that you would be familiar with. But most of these things are like batch jobs, right? Something that starts up, does some computation, and then turns down. And in fact, the biggest like portion of them is like Flume, which is a kind of equivalent to Apache Beam. So these large distributed batch jobs. So not just something small, but like something that spins up tens, hundreds, thousands of workers who do some work and then turn stuff down. I guess the challenge in that is, you're building something that will be used by like thousands of teams. So you need to build some kind of generic, very flexible solution. And you also are trying to build something that integrates and fits with the existing offerings for servers and for other pieces of infrastructure. So, it's not a kind of a true greenfield project in the sense that you're not just like developing something new from scratch. You're developing an extension to an existing thing specifically to support batch jobs. So it being kind of Google-wide means you need a lot of alignment of different stakeholders, and but yeah, it was super educational like project. Definitely something learned a lot about. And again, I thought I would leave that team sooner than I did, but things were great, so I didn't. But
And what was your first AI project then?
Well, yeah. So my first fully AI project in work. So yeah, let me just say where I was kind of doing in parallel. So in parallel to this 4.5 years, I did a master's in software engineering part-time. So that was kind of filling in more of my software engineering gaps, which was great. And I was continuing to like read ML papers. Like I was continuing to do the occasional Kaggle competition, and I had friends who were very into ML, so we would chat about it a lot. But I had never worked on an ML project. I had never been a ML engineer or worked on a kind of pure AI type role. So then in the middle of 22, or even earlier, Q1 of 22, I was looking for my next opportunity. And that was when I wanted to do like a machine learning role. So I was very much like, it's machine learning roles. That's it. I'm not considering anything else. And I found this role that caught my eye in Google Cloud AI, doing what was later a product we released called AML AI, for Anti Money Laundering AI. So the listeners can Google that. It's a Google Cloud product. And that was really interesting because until this point, I had learned a lot about machine learning through my master's, through my postgrad things, through reading a lot, through taking a bunch of Coursera's, but I had never worked with ML engineers. I had never really put it to the test. It was all like, here's my theory in my head. And a lot of it I have never even spoke to anyone about. I had like read these papers and I had never heard anyone say these words out loud. So I didn't know when I joined this team like how behind I'll be, how much I'll have to catch up. And I was a little bit of imposter syndrome for a while, but I was pleasantly surprised that I knew a lot of stuff. I think it took a few weeks to like win over some people, but I think when I explained to people how stacking works correctly, then people were like, interesting, I didn't know this. Our research team knew it, but some of my colleagues were like, they didn't believe me first, but when I showed them all the citations, they were like, yes, you deserve to be here. And I was like, fantastic.
And is the job as good as in your dream?
I mean, like the interesting projects were super interesting. Like, I'm a bit of a workaholic in the sense that I love what I do. So like, I'm always like floating around ML circles and reading papers and things. But a few times I was doing projects that I also found so interesting that I'm just going to do it in the evening or at the weekend, we had one problem where, one of the managers said it was impossible. So then I was like, challenge accepted, and worked through the weekend.
The problem?
Basically, we had a distributed machine learning system and it was not deterministic. And when I say deterministic, I mean that if you set the seed, you get the same result every time. And many of your listeners, I assume, are familiar with like how random number generation works, how you set the seed, you get this reproducible behavior. But it's actually a lot harder in a distributed system because you need to ensure, like, not just that you set the seed in 4 places, say, but rather that like all the possible sources of like non-determinism are fixed. So for example, if you use one of these like MapReduce type frameworks like Apache Beam, it doesn't give you a guarantee on the order the examples are written out as. And so that will affect the mini batches that you will get. So you need to ensure that the order is fixed if you want to ensure that you have this reproducibility. Or similarly, if you use certain algorithms, they are themselves not deterministic, these kind of efficient kind of scalable algorithms. So for example, if you look at quantile transforms, they tend to be not deterministic, right? Because they approximate the quantiles and the approximation changes run to run. And usually there's some parameter you can set this will give you like your approximation error. But again, it's not like deterministic. So, like, and not only that, I mean, in general, there's also some unknown number of bugs, right? Like if you have a system that's not deterministic, you don't know why it's not deterministic, right? Some things you can maybe say, okay, well, we forgot to set the seed. Okay, we had to set the seed. It's now maybe less not deterministic. But and you also, like, sometimes as well, these things are not trivial to test, right? Like if you have a Colab notebook and you can just rerun your cell, it's easy, right? If you have a like distributed machine learning system where running it takes 17 hours, you want to run it multiple times, what is even the process of running it, and what is the process of, testing, verifying changes? So these are kind of funny challenges, and super interesting for me to like work on and solve some of them.
And so you joined this Google Cloud AI team. What is the team doing actually? And can we dive maybe into one AI ML project, Anti Money Laundering, for example, or another one? Can we dive into more details?
Well, I mean, I don't want to give, I can't give too many details, but so like the AML AI product is a supervised learning type problem, right? It's like there's historical data where you have like labeled money launderers and unlabeled or like reviewed but like not money launder, like not found to be money laundering. And it's about training a machine learning model to predict on the kind of unlabeled data which ones are money launderers. Now, in terms of like how you get there, I mean, as a data scientist, you're familiar, you can kind of build some kind of prototype, some kind of baseline, and then you can kind of build more and more powerful models and hope that your performance improves. But also, like, it's a software problem, right? It's about making this thing kind of robust and reliable and scalable. And so you're kind of trying to balance the two kind of pillars. So it's not just about increasing the performance number, but also about, making things cost effective and robust and stable and a good user experience and whatever else. In terms of that, like, we did have different teams that had different sort of focuses. So I was on what was called the machine learning quality team, and they were in theory tasked with improving the machine learning prediction quality, but we still did some infrastructure work. And we also had an infrastructure team who basically exclusively did infrastructure work. So it was kind of both was going on. But, our team did more of the ML type work. I guess a lot of my work, like, and again, this is something that maybe isn't obvious if you don't work on machine learning systems, but it's something you very quickly learn when you spend some time with them, is evaluation is a really hard problem. Like, a lot of machine learning systems are really noisy. And what I mean by that is that, when I spoke about determinism a second ago, determinism can lead people down a kind of the wrong path, which is that they start thinking, okay, now that we've got determinism, now that we set the seed to 42 and we get 82% on our evaluation, if we change something, anything, and we get a different number and it's greater than 82, that's good. And if we change something and it becomes less than 82, that's bad. Now, this is completely the wrong way of thinking, and it is completely a problem that is made worse by determinism. Because ultimately the 82% that you get is like one realization from this random distribution that you're now holding fixed. That, like, if you were to rerun that same thing with 30 seeds or 100 seeds, you'd get a bunch of numbers between 78 and 85. 82 is just one of them. And when you want to make a change and measure it, you need to do 100 samples on that side and, look at the distributions and look at the average of those distributions and do sort of what's called sort of experimental design and statistics to measure whether your change is beneficial or not. And so a lot of my work ended up being there in kind of like building out a kind of more robust framework for evaluating these changes and trying to manage the variance such that you were more accurately able to measure the impact of small changes.
But and so going back to like more high level, the Google Cloud AI team, like what's the role of your team? Is it to build, for example, this anti-money laundering project? Is it to build it for other companies, for internal teams? Like what's your role within Google?
So the way the company was structured then was that under Cloud AI, there was like different verticals for different industries, and financial services was one of the industries. And so the Cloud AI financial services team, which is what I was broadly part of, was building different products, like AI-powered products for financial services companies, banks, financial institutions of various sorts. And Anti Money Laundering was one of those projects.
Okay, very clear, super clear.
And so it was for external customers. Like I say, your listeners can check out the product website, and if you happen to own a international tier 1 bank, you can sign up and use it too.
And so they can sign up and use the model without needing to train it, or
no. I mean, if you're like, it's a product aimed at like tier 1 banks. So if you're like owning a tier 1 bank, then you use Google Cloud, or if you want to use Google Cloud, then you can use it. So it's not something that like you or I would have use for. But yes, how it works is that they would put their certain data into like BigQuery, and then they would use this product which would train models and serve those models for the bank and potentially do inference over new data sets for them and give them back like lists of prioritized leads to review for compliance reasons.
Okay, I see. Very clear. So they put their data in BigQuery, they use Google Cloud basically, and then you build products for them, I guess, so that they put their data in your platform, and also so that they, to incentivize them to put data in your platform, I guess.
Yeah. And like, I said, the solutions were not like built for one customer, but like built for, the idea that it could tackle a kind of broader industry problem. And then, once you've built it with one or a few, you can kind of extend it to others.
Cool. And then, so I believe after that, you joined another team, right? Now you're more working with LLMs. You tried, quite a lot of different teams.
Worth going on a little tangent there. So I joined Cloud AI in the middle of 22, right? So that's before ChatGPT happened. And then in the end of 22, ChatGPT was released, and everyone knows how that went. And literally this day 2 years ago, I went to a meetup here in Zurich, and I had been going to AI and machine learning meetups for years. And until that point, they were mostly like male, mostly statisticians and software engineers. And then I went to this one in this day 2 years ago, and there was like all these normal people there, like people who had other jobs who were not tech people. There were, much more diverse group. There were women, lots of women there. It was like a whole different world. The AI scene had like changed overnight, and it was super interesting. The reason I know the date is because this is the date I met my girlfriend. So it's our 2-year anniversary today. She'll like
Happy
that I plugged
birthday.
that, Happy anniversary.
You're recording a podcast for your 2 years anniversary. I'm honored.
Well, she went for dinner with her friends, so but yeah, so the whole scene had changed, and so when I saw how excited everyone else was, I became more excited. And so at that point, I started building all these ChatGPT API powered applications in my spare time, and like I just thought that how cool it was that I hadn't been paying attention to NLP as a specific subfield for a few years, but it had really moved on since I had been last playing with RNNs in like 2016. And I was just super excited about the LLM space. So I waited until Anti Money Laundering AI had launched, until it had gone to market. And shortly afterwards, I started looking for my next role, and I knew it was LLM focused. And I found this role that looked interesting to me, which was figuring out how to leverage LLMs and AI for internal infrastructure use cases. So like, how can we make our internal infra easier to use? solve problems, automate things using AI. And I happened to know some of the people who were working on the team. I knew the manager, so I knew this seemed like a good fit for me. So I reached out, applied, joined, and it's been great. I've really gone down the kind of knowledge management rabbit hole, so I'm focused a lot on RAG. I think that's like the most commercially useful like outlet of LLMs today. And I could talk for hours about that.
Yeah, no, go ahead. I'm interested. Like, what kind of RAG are you building? What are why is it? Do you think it's so powerful? What are the use cases? I'm keen to go deeper into it.
Yeah, I mean, I think that big companies have like a huge amount of like internal information. I mean, the longer the company is there, the more information they have, right? And so finding things and sort of synthesizing it is sometimes the challenge. And with RAG, you have effectively a search engine, equipped with an LLM, or an LLM equipped with a search engine. And if you correctly like index and store your data, that you can retrieve it for the LLM and generate the answers, you can really just save people a lot of time. I mean, personally, I find it super useful. And I think there's also a lot of space to think where this goes in the future. So, like, obviously everyone's familiar with the kind of naive RAG use case, what's sometimes referred to as frozen RAG, where you break all your documents into like little chunks and then you just embed them, semantic search for the little chunks and put them in the prompt and answer it. And that's, I think, like the V0. And I think there's still a lot of value there. I don't mean to sound like dismissive or anything. I think that's still really valuable. But I think that, if we think about putting more compute into indexing time, more structuring our data such that LLMs can do better, that we can better use them, that we can kind of not just naively put random sentences in the prompt, but that we can do sort of other computation, that we can enrich our chunks. If you look at Anthropic's contextual retrieval, or we can generate like document level or broader sort of summary chunks, that can be also like added to our data set to answer kind of broader questions. And these can kind of fix a lot of the failure modes of these sort of simpler RAG systems and just add even more value.
How does that work? So usually you're chunking you've got your entire document and you're chunking it by sentences or group of sentences or whatever. And then you try to retrieve, when you ask a question, you try to retrieve the chunk that's the closest to your question, or I mean, there are different retrieval techniques, but that's kind of the goal. What are you suggesting?
So I tell your readers to, or your listeners to read Anthropic's contextual retrieval blog post. Okay. It's amazing. But to summarize, what they do is, they take a document and they break it into many, many small chunks, as we're familiar with. And then what they do is they cache the document using context caching. And then for each of those small chunks, they ask an LLM, so in their case, Claude, to contextualize this chunk given the document, right? And so what the model does is it enriches the chunk, which could be a sentence or a paragraph, as you said, with a bunch of the missing context from the document. Okay. So the example they have is something like they have a SEC filing document for some made-up company, and there's a sentence that says, in Q3, the revenue was 10 million for the company. And this sentence doesn't say what the company was, what year it was. It doesn't say what the document was. And so, yes, you can embed that. And yes, a kind of query like company revenue Q3 will find it. But if you give the company's name, that doesn't help. It makes it less likely to find it. So when they contextualize this chunk, it becomes, according to the 2023 SEC filing, company ABC Limited had Q3 revenue of this, up from whatever, previous quarter, and so suddenly you have this enriched chunk. And this enriched chunk is useful for both semantic search, because now it has much more meaning, but also for lexical search, because now it has a bunch of keywords that were not present in the original chunk.
Okay, makes sense. So they kind of link the chunk with the context?
Yeah, exactly. And I mean, I think there's a whole range of ways to take this idea and do it differently. Like they're obviously saying context cache the document and then iteratively run every chunk through it. But like the same idea could be approximated by like summarizing the document and having some kind of brief summary that goes with the chunk, or maybe embedding the summary and interpolating it with the chunks embedding. There's a lot of ideas that could go in a similar space. And then the other thing that I mentioned is what's called QFS, or query focused summarization. So one thing that these naive RAG systems fail at is these broad knowledge base sized queries. So when you ask it to summarize a book, even if you have chunked the book and put it in there, it can't summarize the book because all it can do is find sentences or paragraphs from the book.
Yeah.
Right. So it's funny, right? It can like tell you like little paragraphs about someone, character or whatever, but it can't like summarize the book. It can't summarize the sort of knowledge base or some entity. And now if you have like a RAG system where you say like K is equal to 10,000, maybe you'll just get so many hits that you'll kind of approximate a summary of the book. But what some of the research in this space, there's a thing called Raptor from Stanford, I would check out. But what they do is they chunk the document and then they cluster the chunks in a sort of hierarchical fashion, and they generate summaries of the documents that go clustered together, and that becomes new chunks, and then they repeat the process a few times up to like the document level. So at some point they have a sort of effectively a bunch of these synthetic chunks on top of their regular chunks that can also be retrieved, and then these can answer these QFS type questions. And again, these things can be sort of stitched together with the raw chunks. So when you ask a question that kind of says, what was this character's role in the overall story? Maybe you catch a overall story chunk and several chunks about the character, and you synthesize an answer that you just couldn't have with only the random sentence paragraph mode.
So here we talk more about retrieval, right? Like improving the chunking to improve then the retriever.
Yeah, so what I'm suggesting here is like more index time compute to generate more, like to sort of synthesize more chunks of kind of knowledge that can then be indexed and retrieved.
Is that what you're exploring at Google then?
Yeah, I mean, that's definitely what I'm pushing for more and more, and I'm seeing a lot of evidence from different companies that this is a kind of this is a way forward.
What are the other challenges or improvements that you see can be done in RAG?
Well, I mean, like what other improvements in RAG? I mean, a lot of the other directions are kind of also being like pursued, right? So obviously one of the big ones is this agentic RAG, this idea that instead of it being a pipeline that always just takes a query, embeds it and searches for K items, that effectively you have an LLM as an agent that chooses to use a sort of search tool and gets back some context. Where this is really nice is decomposing queries. So if you have a query like compare A versus B, you have two problems, right? First of all, it's good if there's a document that already has that as a topic, and then you can just mostly use that. But oftentimes what you have is there's a lot more documented about system A than system B, and you end up with a search result that are dominated by, one or the other. If you have this ability to decompose queries, then your model can make a query for A and a query for B and get like 5 of each or 10 of each or whatever it wants. And that works a lot better. Of course, the problem is with this like query decomposition is that depending on the model, it doesn't always work, or doesn't always work the way you'd want it to work, especially because a lot of the models, a lot of the sort of domains you're using it are sort of out of domain. So like these publicly trained models that are trained on public data sets do not understand internal company semantics. So when you mention a system name or something, it doesn't actually know what that is. I mean, you can obviously put something in the system prompt that explains the key systems, but it's not a thing. I mean, I think as agentic things increase in reliability, this will become even more awesome. But I also really like the idea of, and this is where I think there's a split in the RAG community. One thing is, if you think about these thinking models and tool use together, then in theory, these models, given an infinite context window, should be able to answer any question, right? And this is what I think these deep research models are kind of doing at a high level. They're just doing like several retrieval steps, like a lot of thinking steps, some more retrieval, some more thinking, some more retrieval, some more thinking. And then 30 minutes later, you get a response, right? And that's obviously awesome. But, what I'm arguing for with more indexing time compute is, if you can assemble a lot of the important information together before the fact because it's related, then you can obviously make the query time much faster, right? It doesn't have to take 30 minutes if you've pre-computed and synthesized it before. Like if you think about the human case, right? We have Wikipedia. Like if I asked you questions about Germany, you would just go to the Wikipedia page and you'd have like reliable knowledge base that you could kind of use, right? You don't have to go and read like ancient documents to try and see what year whatever happened, or find the census from 2016. So like if LLMs had similar quality knowledge bases that could be assembled automatically, then that would be like super valuable for any company and for the world, I suppose.
Cool. Yeah. No, super interesting, and definitely lots of things that can be improved. Agent is like the big topic of 2025, so I'm sure we'll see more about this. I want to ask a few questions more around Google in general. Like you've been at Google for 10 years, so one that I asked at the beginning is what changed between 2013 and 2025? Like what changed? How did Google evolve? Or is it still the same, maybe?
I mean, it's always changing, and I think the fact that I changed team so much makes it a bit harder for me to estimate when a change was the company versus when it was just that I just like jumped to a different part of the company. Because it was always the case that different areas have like slightly different cultures. Some areas were known to be more hierarchical or more bottom up, more relaxed versus more stressful. So when you change to one of these, you don't know, like, did the whole world just get more stressful, or did I just move into the stress zone? I do think like the company is undergoing like a, how would you call it, like a shift, a kind of culture shift over the last few years, from being very, very bottom up to being more sort of top down, more kind of directed. I think you even see this sort of publicly, where I think that there was, like, if you think about like the DeepMind of pre ChatGPT, they were publishing all sorts of awesome things, all sorts of directions, like you didn't even know what they were going to publish next, It was like, if you can do something awesome, you can do it at DeepMind. I think now it's much more like, maybe it's increased competition or whatever, but it's much more like focused on delivering things and kind of being kind of directed. I mean, it's not like fully strict or controlled by any means. I don't mean to say that it's like, really, that you has no freedom or flexibility. Quite the opposite. Like, it's still a great place to work, but it definitely feels like there's less room to do kind of random things. You need to work harder to justify what you're doing if it's not what they told you to do or asked you to do. I think it might have been easier in the past to just be like, you're doing something and it sounds good, so keep doing it,
But you've been there for like 10 years, so what do you like so much about Google?
What keeps me there? I mean, I think probably the thing that's kept me in Google for so long is the flexibility and freedom to do new things and move around and try new things. Like, again, I haven't worked at all these other companies, but I do hear that, like, in some other companies, they make internal mobility really hard or impossible. They don't allow or encourage you to change teams. Whereas in Google, it is and was very encouraged and very enabled. And to me, it's a huge boost because, when I'm like bored of a project, or if I'm frustrated with like my leadership or management, I can just change to a different team and then continue my great work elsewhere,
Yeah, the team you've gone through are so different that it's almost like you changed company, I guess.
But that's true, right? Like, it's so big that, like, you'll change team and no one you work with knows anyone from the old teams, like, at all. Like, even if they're in the same like office. I mean, Zurich is like 6,000 people in Zurich office, and that's like not that big. I mean, so yeah, I mean, and sometimes you'll change team and have a whole different tech stack. Like, if you change to something like Android, you might be like committing things to GitHub repos and open sourcing everything, and then you change to something internal and it's all the internal stack, or you change to a cloud team and it's all Google Cloud you're building on. So you can learn a very broad set of skills if you want.
So let's maybe finish the episodes with more of a career question. If you had one advice for people to progress in their career, just one advice, what would it be?
I mean, one thing that I always say to new people, and I'm almost always disappointed they don't listen to me, is I think you should really like own your career and not expect someone else to do that for you. You know, you should really think about what you want to do, what you want to achieve, where you want to get to, and push for that. Like, you know, you shouldn't wait for your manager to suggest what you should specialize in. You should already know what you want to specialize in if you want to specialize. You know, you shouldn't just like in a company like Google. You know, there's often there are things you can do. You know, you can go to conferences, you can do trainings, you can, you know, do rotations if you want, you can visit different offices. Take advantage of these things if they're available to you. Like, but you're not pushed to. I mean, you don't have to. But if you want to do that, like if you want to grow your career and grow your network and your whatever else, you know, those things are there. But most people, they think, I don't know, maybe they think I'm crazy. Maybe I am crazy.
No, you're not. I mean, everyone is crazy in some sense. Well, yeah, Max, thanks a lot. It was great to have you on the show and learn a lot from your super interesting career. So yeah, thanks. Have a great evening, a great weekend. And yeah,
thanks so
hope
much.
to catch up soon.